Hi, Geometry. This is Unit 3, Lesson 6, and I'm on page 353 of our workbooks. Are these two triangles similar? Actually, yes, we're going to find that these two triangles are similar. So let's take a look at our given information. AB, let's go find AB, that's this little guy down here, is parallel to QR, okay. AB is perpendicular to AE. I can see the right angle mark. And here I can see the QR is perpendicular to QT. So in this problem, some things I'm noticing, let's look at the angles first. It looks to me like the corresponding angles, the angles that match up, the corresponding angles are congruent. So let's go take a look at that. E and T both have a single arc with a tick mark through it. A and Q both have a 90-degree angle mark, and B and R have an arc with two tick marks. So it looks like all three are congruent to its corresponding angle. Let's see about the sides. I want to see if my sides are in proportion. So remember, to be similar, my triangles have to have the angles congruent, corresponding angles congruent, and the sides in proportion. So let's take a look at that. It doesn't really matter which one I put on top, but I'm going to treat my larger triangle as my original, and I'm going to treat my smaller triangle as my image. Sorry about that, image. So when I go to write my proportions, I'm going to write it with my image over my original side. So let's get started on this one. For my big one, 15, if 15 is my original, then 6 would be my image. 6 over 15 can be reduced by 3. If I reduce them both by 3, it looks like I'm getting 2/5. So now let's do maybe this side right here that's 8. That's my original. And it goes to a side that's 3.2. So it's kind of hard to see. If I multiply them both by 10, it'd be 32 over 80. You can reduce 32/80 down to 2/5, but I want to show you guys some stuff. So first off, I can check to see if it's 2/5 by simply doing 3.2 divided by 8, and I get 0.4. And if I want to check to see if I didn't realize that this is 4 over 10, then I could always do 2 divided by 5 and see that I'm getting the same answer. So if I used my calculator and got 0.4, I'm still getting 2 over 5. So far, these two pairs of sides are in proportion. But you know, your calculator does this for you. If I do 3.2 divided by 8 and I get 0.4, if I go down to this button right here, do you see the button at the bottom with the green F to D? If you're using this calculator, you would want to hit the green button so that you could do the green F to D that's above. So touch the green button and then touch this button, and that changes it to the fraction 2/5. So this is another popular calculator. It comes in bright blue, white, pink, green, turquoise. So I can do the same thing here. I could do my 3.2 divided by 8, and this should be easy. I'm hoping that everyone can realize that 4/10 does simplify to 2/5. But let's just say you want to use the fraction and decimal key on this calculator. It's above the probability key. You can see the F to D in blue above this. So you'll want to hit the second button, the blue button. And then when you touch this, it's asking, do you want to go fraction to decimal? Yes, I would like to switch it. And it switches it back to the 2/5 for me. So just something that you might find very handy. And so that would be handy on something like the next one, where my original is 17 and my image is 6.8. Again, if you divide those, you should get 0.4, which is also equal to 2/5. Do I care whether you use a decimal or a fraction? Not really. So I just hope that you can go back and forth. Whether you listed this as 6 divided by 15 is 0.4, 0.4, 0.4. Notice it matches, it matches, it matches. Great. Or if you had 2/5, 2/5, 2/5, great. So what you're showing me, though, is that indeed our sides are in proportion. So these two triangles, triangle ABC, is similar to triangle T. Now I've got to match it up. Sorry, A goes to Q, B goes to R, and oh, it's E. Sorry about that. Let me change that to an E. That was an E up there, and E goes to T. So they are similar. My corresponding angles are congruent, and my sides are in proportion. So I also want to talk about now doing a transformation with. So you can pick up more patty paper when you get to CDM with me in the hybrid schedule, but it says to write a sequence of transformations. So that's the dilation, translation, rotation, reflection, to take one triangle onto the other. So we're going to take the original. We're always going to move the original to the image. So remember how I set this up. My original was the larger one. So I'm going to just trace this here to show you how I'm thinking out loud. So this is my A, B, E, and I need to translate one of these three vertices to the matching one. Does it matter? No. You can take E to T, you can move A to a Q, or you can move B to R. It doesn't really matter. All of them is fine. So you just need to say translate, and you need to move one of them to the other. I'm going to say A to Q just because that's the notes that will be in the folder. And then once I've translated A to Q, they're setting together. They're setting right here. I need to dilate this back. I need to shrink this EBN with center A. I need to shrink it in so it now becomes this side that's 6.8. I need to shrink it by the scale factor of 0.4 or 2/5. So I'm going to dilate this. So now I'm going to dilate this around. So when you dilate, you always have to have a center. Around center C by scale factor. And now it doesn't matter if you write 2/5 or 0.4. Usually it really doesn't matter. So you could rewrite this and you could have the 0.4. So you could have also wrote or 0.4 and it would have still been correct. So this is how you can describe a sequence of transformations. So this is a lot like Unit 1. You might translate, rotate, or reflect to get the big object or the small object on top of the other one. And then your last step is to shrink it up. You're going to shrink it, or maybe the problem is you need to make it larger, and then you're going to have a scale factor that's greater than 1. So for number 2, it says write a similarity statement about the two figures and explain how you know. We've talked about several ways. 1, we could do this sequence of transformations and it worked. 2, we showed corresponding angles and sides in proportion. We've already stated that they're similar. So we really also already done 2 above. So what I do want to write here, though, is the definition of similarity, our official definition. So right now, this is the definition of similarity, and it has to do with these transformations. So the definition is the figures are similar because a sequence of rigid motions and a dilation take one onto the other. So this is very familiar from Unit 1. If you remember the definition of congruence. The definition of congruence wasn't that they were the same size. It wasn't about the sides being equal. It wasn't about the angles being equal. The definition of congruence was that the figures are congruent because a sequence of rigid motion transformations took one onto the other. So here, this one is that the figures are similar because a sequence of rigid motions plus now you're gonna have to do a dilation. Either it's gotta get bigger or it's gotta get smaller to take one onto the other. So that's our official definition of similarity. So going to your homework, number 3 on page 355, I want to mention it has some things that all kind of make sense. I want you to think about what is the definition. So if you could turn to number 7 on page 356. This is actually not new, page 356. This is coming from lesson 4. Last year, A didn't really throw very many people for a loop, but B did. So I thought we'd just look at this one as we're finishing up this video. So let's take a look at this. It says, respond to each question. Dilate point C, that's my point C, using center D and scale factor 3/4. So I'm going to dilate C on this line to get C prime. And my scale factor is 3/4. So this is a reduction. The distance is going to shrink. So if this is my original distance that C is from D, my new distance is going to be 3/4 of that. So I need to figure out what that is. Remember, my image is equal to my scale factor, in this case 3/4, times my original. Let's go find my original distance. It's kind of hard with the binder rings. Let me take this out. So my original distance, this is looking like, it kind of looks like 25 to me, although that's not a very easy number to multiply by 3/4. So let's put that 25 millimeters into this. And if you get out your calculator and you do your 3/4, 3 times 25 divided by 4, looks like we're going to get 18.75 millimeters. So the distance from C prime to D is going to be 18.75. Well, how do you mark that? Just go a little farther than 18. So let's set this up. If I turn this so D is at 0, then 18 is 2 tick marks before 2, and 19 is 1 tick mark before 2. So I'm just going to put something in between 18 and 19. I'm going to call it a day. That's approximately where my C prime will go. So the total distance, as a reminder, between these two was 25, and this distance was 18.75 millimeters. So that one was pretty easy for a lot of kids last year, but the second one, it says dilate the segment AB. So there's this little segment on here. It says dilate the segment AB using center D and a scale factor of 1/2. So don't think about doing the whole segment at once. Dilate A from D by a scale factor of 1/2 to get A prime. Dilate B by a scale factor of 1/2 around D to get B prime. And then you'll have A prime, B prime exactly where you want it. So let's do that. In this case, we're going to measure how far A is from D. It looks like if I put the 0 on A, it looks like it's about 8. So it looks like then my A prime would be at 4. At 4 tick marks away from D. So that's about right here. And so this is where my A prime would go. And so now I'm ready to do B. So I'm going to measure the distance from D to B. So as I'm measuring the distance from D to B, it looks like it's 25 again. 25 is kind of hard to divide in half. What would 25 be divided in half? 25 would be approximately 12.5. So this is 1, 11, this is 12, that's 13. So I'm going to kind of just mark it somewhere in between 12 and 13, the 12th tick mark and the 13th tick mark. And this would be B prime. So what I've really done there is I have moved this segment that was AB, and I have moved it so that now it's half as big, A prime to B prime. And I've moved it closer to D because that's what happens when I do a reduction. And so that would be where my new A prime B prime is at. Thank you very much.